So this video is about partitioning. In this first example, I want to do a simple list partition. I've actually created it, so let's take a look at it. Okay, so in a list partition, you create your table, and actually want to partition by list on the second column. And it's pretty easy. You start with this is the tricky part, I guess, is that we start with partition A, values A and values B, and in this case values C and D, and if it's a null value we can say values null, and if we don't know what it is we can say default. So each of the values got to be encapsulated by parentheses, and the whole partition listing is it's also captured by or encapsulated by parentheses. So let's just go ahead and create it. And I'm just going to look at it one more time. Oops, sorry. So in this next example, I want to do a simple range partition. So the range partition syntax is not terribly different from the list partition syntax. Let me give you an example. So in this case, we say we open up, we say partition by range, and we give it a particular column. And in this case, it's a date column, but it could have just easily been a number column, and I could have specified numbers here. In this case, we still put the values within parentheses. Notice there's multiple parentheses here because the value itself is a 2 timestamp, so there's a function within it. So there's multiple parentheses here. Now, for a range partition, you always say values less than. And another little interesting little wrinkle here is I specified a particular table space for those partitions. And finally, there's a partition Pmax, which is values less than the max value. So when a particular, in this case, a sales data comes in and it's not part of the not in any of these ranges, then it'll fall into Pmax, and you might have to split that later. So in any case, this should just go ahead and work. So let's take a look at it. Let's look at it one more time, and let's run it. So in this section, I want to talk about interval partitioning. I want to create a simple interval partition, and let's take a look at an example. So in this example, so to do an interval partition, you have to specify an interval. In this case, I'm specifying 1 month. And also, interestingly, you can use this particular syntax. So this will do a round robin into different particular table spaces. So we'll start with T1, T2, T3, T4. And in this case, I'm specifying 4 partitions to start with, but I don't have to. I can just start with 1 partition. So I think that's what I'm going to do. I'm going to rewrite this and just do the 1 partition. So let's take a look at that. And let's go ahead and get rid of these. So in this case, interesting, I could have said 2 timestamp. In this case, I did 2 date. So not a problem though. So let's try it. Done. So in this section, I want to talk about virtual column partitioning. I do remember that a virtual column was required someplace in the fourth OCM exam. They did say something about no unnecessary columns, which means sounds like a virtual column to me. So I'm going to actually give you an example. This example comes from the VLDB and partitioning guide directly. So if we have to create a table like this, I would look at the syntax that's in chapter 4 of the VLDB and partitioning guide. So let's look at view virtual. Okay, so in this case, we're creating a sales table. The virtual column here is total amount. Total amount is the quantity sold times the amount sold. So this is the syntax to do the virtualization of that particular column. But there's a lot more going on here. First off, there's a partition by range on time ID. So we're going to do a 1 month partitioning. So the partition is partition by range, but also I'm trying to figure out this. Let's take a look here. Where's this little creature? Right, okay, so the interval here, so when we specify the interval, we put the interval within parentheses, and within the parentheses we actually have a function num to interval, num to year min interval, and ym year month interval. So here we go, 1 month, and then but then we do the subpartitioning here. So we say subpartition by total amount, which is the virtual part. Then we start with a subpartition template. So for each partition, there's a subpartition. We're going to call it P small, P medium, P large, P extreme. And so we specify a range for that, 1,000, 5,000, 10,000, and max value. And then we go back to the partition. So we have only one partition because that's all we need for an interval partition. And then, in fact, we do the enable row movement. This is important because if we do any updates or changes on this particular table, the the total amount could move the total record from one partition to another. So we need to enable row movement so that a record could move from one partition to another. And then finally we're doing parallel no logging. This just means that we can do this in parallel and there's no archive logging to build this particular table. So without further ado, let's go ahead and create that. But don't sweat this syntax too much, because this is found right in the documentation, and we can just cut and paste this. So let's go ahead and do that. So in this section, we're going to talk about reference partitioning. The example I'm about to run comes right out of the documentation in the VLDB partitioning guide. And let's just look at it, actually. And aside from the name, it is exactly a cut and paste of that example of reference partitioning in the administration section of the VLDB and partitioning guide. So notice that we have a table called orders and a child table called order items. The primary key is on order ID and the table is partitioned. And here the child table has a foreign key constraint that 2 order items, and all we have to say here is partition by reference. And so, so without further ado, let's just go ahead and run it. One thing I wanted to note to note here is that we use partitioning but not interval partitioning. If we try to do interval partitioning, we get an error. I'll actually run that as an example, and you'll see it. So let's go ahead and run it. Okay, so we created two tables, and let's look at the partitioning associated with it. Okay, so what I want to do is look at the partitioning for these two tables, both the parent and the child. And notice that both the parent and the child have four partitions associated with them. And so a simple partition by reference takes care of that. The other example here is I redid this example so that this is called orders 9b, and the only difference here is I tried to make this an interval partition, and as soon as I did that, you get an error. So you can't do interval partitioning and partition by reference at the same time. This section is on partition compression. Partition compression can be done at, first of all, you can do it at the table level, and it will compress all the partitions, and you can also do it at the individual partition level and or override the compression, and I'm going to show you all three examples. So let's look at the first example. So this first example, I have a costs demo table, and I'm partitioning them, and I'm pressing compress for one particular partition and not the others. In the second example, I compress at the table level, and I'm going to show you that they will compress all the partitions in this particular case. And then the final example, this is an index that's on the first table, and we're doing compress local, which means that it will, local means that it will do partitions for all the partitions that are in the table, and it will compress each and every one of them except for this one called cost recent, which I'm going to override and say no compress. So I'm going to go ahead and run these three, and then we're going to query. So let's go ahead and do that. So now let's query this, and let's start with the tables. So I'm going to look at DBA tab partitions for the two tables I created, costs demo and costs demo 2. In the case of costs demo, I decided to compress only one partition and not the others. In the case of costs demo 2, I did it at the table level, so therefore it compresses all of the partitions in that table. And in the third example that I ran, this is an index. Let's look at that. So in this particular index, we get the same partition. This is an index on the cost demo, the first table, cost demo table. So we get the same partitions, and I did the partitioning at the index level, and it partitions all of them except for the one that I overrode, which was cost recent, so it's disabled there. And that's it for this section. So in this section, we're going to migrate a big table to a partition table, but we're going to be using the exchange partition and split partition approach. So the first step I want to do is actually create a big table. So it's rather big here. This is a lot here, but the thing is, I'm building a table. It's non-partition. It's called Big Table, and then this routine actually starts to populate the table, and what we should also note is that there are some things about this table. One is that there's some indexes, there's some foreign key indexes and constraints, and there's a primary key constraint, and that's about it. So there's some dependent objects, dependent indexes. Okay, so let's go ahead and run it. This takes a minute. Okay, it's done. So the next thing I want to do is I actually want to create a new table. I'm going to call it Big Table 2 temporarily, and it's going to be an analog to the Big Table, except now it's going to be partitioned. So the best way to do that is to capture the DDL of Big Table and then partition it. And the way to do that is to use dbms metadata.getDDL. So let's look at how I would have done that. How do I do that? Okay, so what's interesting about this is that the first thing I do is I'm going to get the DDL for Big Table, but there's some indexes that are not reflected in this DDL. It does give me the primary key index, or the constraints. It gives me the primary key and the reference foreign key constraint, but it doesn't give me the other indexes other than the primary key. So then I look at DBA indexes for Big Table, and I run this again, but using the word index name here from DBA indexes. And if I run it, I get the following. And I set the long to be 32,767 and pages to be 0, and this is what I end up getting. So I get the table definition, and I believe this came with this. Actually, it did not. So it has the primary key in here, so this can be commented out because this came with the indexes. And then it had other indexes in here as well. So that captured pretty much everything of the DDL of big data, and now I'm going to morph this or modify this into to create Big Data 2, and I actually have done that. Let's take a look at that. So what I did first was took the table Big Data and made it Big Data 2. I made all the constraints and all the indexes under 2, have a 2 at the end of them, because later I'm going to rename them back to what they were. But here I partition by range, and I just have one big partition. I'm going to call it Partition Pmax for the max value. I commented out this one because this index is already built with this primary key constraint. And then the other thing that I did here was I created for this date, I decided to make it a local index. So that's a little different. But I kept the lookup ID to be a global index and not partition. So now I'm actually going to run this. So now we're done. So now we have we have the big data, and we have the big data 2, and now we just need to do a exchange partition. So let's look at that. So here I'm altering the big data 2, exchanging the Pmax with the actual big data table itself, and I say without validation and update global indexes. And actually I probably didn't even need to do this because I think it might be better just to go ahead and rebuild the indexes later, but in any case I've done this, and let's go ahead and do it. Just for grins, I want to see what if the indexes are valid, and they are. Okay. So all right. So now let's go ahead and drop the original big table and rename everything. So everything that I had was 2, I'm back to what it was. So now the only difference between big table and big table, the old big table and the new big table, is the partitioning. And recall, we only have one partition, it's called Pmax. So I'm going to do the rename stuff now. Now here I'm going to be partitioning this by year. So I want to know how many years are actually in this big data. And there are 3, 2014, 15, and 16. So then, now I'm going to actually do the split partitions. So I split Pmax at 2015, and I call it 2014 because it'll be less than 2015, so it'll have the 2014 data in it. And I do it in parallel. I could say update global indexes, but it's faster to do it this way and then just rebuild the indexes later, since I'm doing multiple split partitions. So I split the Pmax at 2015 to create 2014. I split the Pmax again at 2016 to create the partition 2015, and I split the Pmax one last time at 2017 to create the P 2016. So go ahead and run this. So now you notice I have the update global indexes part commented out, so it will actually break the indexes, and we can prove that. So this index is actually partitioned, so I have to actually look at DBA IND partitions to see the status of each partition of the index. And you can see pretty much everything is unusable. So now I'm going to rebuild everything, but there are some caveats there. So with the non-partitioned indexes, I use parallelism, and then I alter it back to be no parallel. for the partition index, the only way to rebuild is to rebuild it. You can't just rebuild overall, you have to rebuild each partition. So I say, rebuild partitions, all the partitions that are listed here. And then this one is a non-partitioned index, so I say rebuild parallel and then no parallel. So let's go ahead and do that. And let's run the previous query again. Actually, I call it split 10, but it's the same as split 8. And now everything is usable, and this section is now done. In this section, I'm doing partition migration by DBMS redefinition, and in an earlier section I did the same thing but using exchange partitioning and splitting the partitions. But this time I'm going to be using DBMS redefinition, and it's important to note that there are some really good examples in the documentation, especially in the administration guide in chapter 20. There's an example 1 in chapter 20 of the admin guide, and it does a redefinition using partitioning. So, or I'm sorry, using DBMS redefinition and partitioning. So what is interesting about using the either approach, they also have their advantages and disadvantages. I think the disadvantage in using the exchange partition and splitting is that you have to do all those splits and what have you, and you also have to rename the dependent objects. In using DBMS redefinition, it's done for you automatically, and so I think that's the big benefit here. So we're going to take a look at an example, actually the same example that I used in the exchange and exchange partition and then splits. So let's look at the DBMS redefinition example here. So the first thing I'm going to do is log on and cat def 01.sql. Okay, so this builds our table that we did in the previous example when we did the exchange partition and splits. So nothing to notice here other than we're creating a non-partition table called BigTable. It has indexes, primary keys, and foreign keys, and so let's go ahead and create it. Okay, so it's done. So now let's look at the next script. Cat redef 02.sql. So here, this is nothing different here. I just want to look at the DDL that's created. We've done this before also. I think what's interesting here is that, well, this helps us generate the DDL for BigTable 2, which is going to be our interim table when we do redefinition. But also it points out that something like the create date will be recreated as an index, but a non-partitioned index. And this is probably something you will want to reconsider. You probably want to make this a local partitioned index. So, but we'll talk about that in just a minute. So, I did use this to formulate my interim table. So let's look at what my interim table looks like.
The good part of this is that I can create all the partitions all at once, and notice that I don't have any foreign keys or indexes or what have you, just nothing. When there's a certain point when I copy the table dependents with the redefinition process, it will do all of that for me, and I will show you that. So I went ahead and created the partitions. At some point in an earlier section, I showed how the big table had 3 years, 2014, 15, and 16. And so I included those plus this PMAX partition, which will hold nothing actually. So it's just the fallback. So I'm actually going to create this table. Okay, table's created. So the first thing I want to do when I start the redefinition process to see if big table can be redefined, and this will tell me that. If it produces an error, then you can't. If it doesn't produce an error, then it can. Notice also that unlike the previous example where I think I created all the objects as sys, I'm not doing that here. I'm creating with Soleo because you can't run the redefinition PL/SQL package with objects that are owned by sys. So let's go ahead and run this. So everything is owned by this user called Soleo. So because this procedure didn't fail, or this function didn't fail, that means that it is redefinable using this process. So let's start that. Okay, so here's the start redefinition process, and it's pretty easy. So if you wait a while, then you may need to resync this. This is an alternate. This may not optional step, but if you have a lot of inserts, updates, deletes between the start and before you finish, you may want to do this sync stuff. I'm just doing it just as an example. But since nobody's updating it, it's not a big deal for me. This is probably the most important step here, is the copy table dependence. So in my case, I created Big Table 2 with no indexes, no primary keys, no foreign keys, no nothing. So, but I said go ahead and copy all of those things, the indexes, the triggers, the constraints, the privileges, whatever, everything else. This has to be put into a PL/SQL block because the errors is an in-out variable, or maybe just an out variable, but we have to have that to to run this. So we actually display the errors. Let's go ahead and run it, or the number of errors. There's also, and I don't have this particular column in here or this particular parameter, but you can also specify the columns that you want copied. So in our case, I want all the columns, so it's a null. But in some cases, where if you're maybe making a smaller table, or you're deleting or dropping particular columns, you can actually make the number of columns smaller, and you can map. You can do some column mapping here. So I believe that's actually the parameter name of the column mapping. Okay, that's done. So notice that there's no errors. Okay, so now you've seen this before, where I was doing the metadata for Big Table. Now I want to do it for Big Table 2, and I have a method to my madness here, so let's look at why I want to do that. Because I did this copy table dependence, I wanted to see what happens to Big Table 2. Well, Big Table 2 already had the partitions, but notice now it also has a primary key, which I did not create, but these are these temporary names that Oracle gives during this process. And also it created indexes for me, also some temporary names, because it's doing this process. When it's all said and done, it will rename these the same name as in the previous table. Notice again that the created date will be a local, not a local index, but just a plain old index. So we may want to consider dropping and recreating that. So, alrighty. What was that? That was F. That was 8. So, okay. So now we're basically done with the redefinition. So let's go ahead and do that. Okay, and we're done. And now we're going to run this again, but this time with BigTable because the transfer has been completely done. And we should see BigTable now as partitioned. Oops. I'm sorry. Redef 10. Okay, so now BigTable is partitioned, and the temporary constraints and indexes, the names that they were given, are now being renamed for us automatically. So that's the big benefit of using DBMS redefinition. And last but not least, I want to go ahead and drop the old table, which is now the old table, which is now BigTable 2, is the interim table. I also wanted to drop the created date and recreate it as a local, and then I'm just going to gather the statistics. And now we're done.